Hello and welcome to this installment of Talk Tech with Beck. Today we're going to solve an algorithm. This was one of the two problems given to me during my first mock technical interview after I graduated boot camp. It's the first one that I solved on my own using 2 pointers, and it's also about one of my favorite things, palindromes. So let's hop on in. The problem that we're going to do is number 97. It's called Check Palindrome, and it's on binarysearch.com. It's an easy algorithm, and the problem reads, given a string S, return whether it is a palindrome. So before we go any further, we do need to ensure that we understand what a palindrome is. So this definition that binary search gives us is that a palindrome is a string that reads the same backward as forward. For example, race car is a palindrome, and it is. It's a very good palindrome. The constraints that we're given here is that n is less than or equal to 100,000, where n is the length of S. So we could have a 100,000, a word, a string, we could enter a string that is 100,000 symbols, letters, numbers, whatever, long. And our test examples are, example 1, our input for S is race car and our output should be true. For example 2, our input is for S is evil olive and our output is also true. And then for example 3, despite palindrome being palindrome, it is not a palindrome. So S will be our input and our output should be false. With algorithms, there's almost always more than one way to solve it. The more practice you get and the deeper you go into understanding the algos and the time and space complexity, the more you can really start looking into optimizing the speed that your problems will be solved in. But if you, like me, are on the newer side of things, just do your best to wrap your head around the logic and solve from there. You can worry about optimization and big O notation as you continue to work and learn more. For this problem, my first instinct is to go with a for loop with 2 pointers, since we're comparing 2 items while we move through our string. So first, we have our function declaration. Binary search usually has one already, so this is from them. It is set up just to work with their test. So our function is going to be called solve. Our argument, as before, is S. So when I'm working through problems, the first thing I try to figure out is if there's an edge case that's already being hinted at in the wording of the problem. Since the only constraint given to the length that S should be is less than 100,000, it implies to me that an empty string is a valid length for S. So we can go ahead and take care of this potential situation with just an if statement. So we're going to come right here underneath our solve, and we're just going to say if S is an empty string, then we're just gonna go ahead and return true. Great, edge case checked off. Next, I will be declaring my I pointer in my for loop. So before that, I'm gonna go ahead and declare my second pointer. So I'm just gonna use I and J. So we're gonna say let J equal S dot length minus 1. Since I want to start at the end of the string, it's easiest to find the value of the second pointer by using dot length. But don't forget to subtract 1 since indexes start at 0 and dot length counts start at 1. Okay, so this is making sense so far. So now let's go ahead and get into our for loop. So we're going to say we're going to declare our first pointers. We're going to say let I equal 0. So that will start at index 0. And then while I is less than or equal to j, we are going to go ahead and add 1 to I. Don't forget your curly braces. And now, so we've got our first pointer set at index 0, our second pointer at the last index, which is going to vary depending on the argument we enter. So now we want to decide on some if statements. Since the palindrome is the same forward and backwards, we want to compare these 2 points and make a decision from there. So we could say something like, if the value at index 0 of our argument is the same as the value at our last index, then we want to move our pointers. Our I pointers movement is already defined in our for loop declaration, so we just need to move our j index by subtracting 1. So out of English and into computer, if s at index of I is the same as s at index of j, then we're already a plus plusing, so, or a, we're already a I plus plusing, so now we need to j minus, so we can do the same thing, j minus minus. So that takes care of the pointers comparing and moving if they're the same. So what happens now if they aren't the same? If they're not the same, we're just going to return false, because the first time we hit 2 letters that are not the same, it's over. It can't be a palindrome. So before we write our next statement, are there any other cases that we need to account for? If we go and look back over the problem, it's pretty straightforward. It's one sentence. It seems that there's not anything else to worry about. So we can go ahead and make our last statement an else instead of another if or an else if. So we're going to use else because that takes care of anything that's not a palindrome, ends our loop, and we shouldn't really run into any other issues. So we will go ahead and say else. We don't need to say else what, just else. We don't need this cute little J typo. All right, so else we just want to go ahead and return false. Our for loop is complete. It looks good, but we're not quite done yet. So we addressed our edge case of the empty string. We've looped through our string. We've compared our letters and say all the pairs are the same until we end our loop. Then we want to return. If they're not the same, we're returning false. We've taken care of that. So now we just have to tell the computer to return true. We will want to put that return outside of our if-else statements. So we've got these little curlies and this if, and then these curlies and this else, and then this is our for, so these 2 curlies and that. So we want to make sure we're out of the loop. We can go ahead and add our return true. And there you have it. Let's go ahead. We can go ahead and run. So we've got test case. We're going to run race car. We're going to run it. We're going to get return true. We're going to copy this test case over, evil olive. We're going to run it. We're going to return true. We're going to try this new test case. We're going to run it, and we're going to return true. So something cool with binary search is that once you run it, if you feel good, you can go ahead and submit it, and it's going to actually tell you how fast your solution was compared to everyone else who has done this puzzle. So let's go ahead and submit. All right, my code took 2 milliseconds, which was faster than 93.09% of other people who have solved this in JavaScript. Sometimes on a good day, this can be 100. Oh, see, that took a while, which is fine. That just shows the computers take different amounts of time. I'm in the woods right now. My Wi-Fi might be weird. Let's try it again. There we go. 1 millisecond, faster than 100% of all the other tests in JavaScript. That feels good. Come on, come feel good. Try this out. Get your algorithms on. And there you have it, one fun and easy algorithm that we can easily modify to make more difficult if we want to, for practice. For example, if I were to enter a man, a plan, a canal, Panama into the argument, it would be returned false, despite the fact that a man, a plan, a canal, Panama is in fact a palindrome. In order for this to come back as true with this for loop that we've created, we would first need to figure out how to remove the punctuation, change any capital letters to lowercase, and remove the spaces. If you like this problem and want to keep on going with it, go ahead and try to solve for these new constraints. Thanks for solving this algo with me, and don't forget to like and subscribe.